All right. I guess we are live.
We are.
We are.
Fantastic. So welcome to another episode of EffectTime. I think we're again 1 or 2 weeks late, but I think we have a valid excuse.
We had a Malaga retreat. Come on.
Exactly. So we, Max, Mike, and I, and some others have been meeting in sunny, warm Spain roughly 2 weeks ago, or 2 weekends ago, for the nice occasion of a ZEO conference, ZEO World in Malaga. And so we got to meet up a whole bunch of awesome folks from the ZEO Scala community, and use this as a nice opportunity to also meet in person, which was great. We had a blast, had a lot of good foods, lots of great conversations about Effect and about sort of like the future of Effect, which we also want to progressively share here with you. Today it's going to be fairly normal. Like, we're going to take a look at a specific kind of use case that we consider interesting, and that actually has some practical implications. But yeah, rest assured that we have some really cool things in the pipeline. We've already shared a nice roadmap with you, I think, in the Discord channel, and we're also actively working on the documentation that we're gonna could use some help on in the future. But today the topic will be about file watching. So file watching, maybe if you're in JavaScript and you need to solve, hold on, how do I, Chokidar, there you go. If you needed to ever do like file watching in JavaScript, you've probably stumbled over this library here, Chokidar. And that's what you could use, for example, to say, hey, watch a specific directory, and then for given file events, do something. So I had to do this plenty of times, use this, and Chokidar is, I guess it's all right. I had a few issues with it, however, over the time, and investigated also alternatives. So, and I think the folks working on VS Code, which I typically use as an editor, I think they were using Chokidar in the past, and they've moved over to an alternative. And one set, I'm not sure whether this is exactly the alternative, but one alternative that's increasingly popular is the parcel file watcher. There you go. So this is done by the great folks working on Parcel, and is made available standalone. So this is an alternative to Chokidar that is very interesting. I have actually a few use cases for my own project where I want to use this, but obviously I'm building these projects with Effect, and so I was wondering, hey, is there a way how I can use Chokidar or Parcel Watcher with Effect? And that's what we today want to look into. In the past, I've actually already taken a stab at this when working on content layer. So in content layer, there is already some file watching functionality for the local file source. So I think here in source files, maybe we have it here. What FS Watcher? It's in the utils package.
I think it might be in there's part of it in the CLI as well.
Right. Yeah, exactly. So yeah, this is we've already, and I think this was with the help of Patrick from the Effect community, if I remember correctly. Thanks, Patrick, for your initial help here. This is where we had a Chokidar wrapper for Effect, for like a file watcher, and the abstraction that we leveraged here was the abstraction of a stream. If I remember correctly, or maybe I'm mistaken, we had a, hold on, let me actually take a look how we ended up using this. What do we? I think we had this make and subscribe used somewhere, which we then actually combined here with like a ES build alternative as well. Yeah, and I think here we're turning it into a stream. So we're basically going to take a look today at something similar, but much more refined and based on Parcel Watcher. And turns out that Max has actually already taken a stab at this in the past. And this is why it felt like a good topic to share with you all and dive more deeper into. And depending on how far we get, we'll actually have a real code base and a real package that's a nice building block for others to use. So I think we're starting off from a fresh project today. That's like a fresh monorepo project here. Contains already way too many config files, but at least they already exist. And this will get simpler over time.
Hit allow.
And so here we have, yeah, that's just like a bootstrapping, a bootstrap project where we can now use as a foundation to build the file watcher. And I think once we've built the functionality and the test, maybe we have enough time to build a little example app with it as well, maybe using the effect CLI package. But yeah, that's sort of the scope for today. Really excited to dig into this. I think it's going to be useful for many others. Certainly going to be useful for me in the future. And yeah, without further ado, I would hand it over to Max. That Max can sort of like take the driver's seat and walk us through building this little module from scratch and seeing what it takes to build this in effect. So yeah, and for those who have joined the call live, welcome. And if you have any questions in the meanwhile, feel free to ask them using the chat, and we'll weave them in. All right. Then cool. Max, I'll stop sharing my screen and you can take over.
Sounds good. Yeah, if anybody has any questions, you can either post them in the chat here or post them in Discord. We'll try to answer them as we can. Let me make sure I share the correct screen. This one. Can you guys see my screen?
Yes,
we can.
You might want to bump up the font size once.
Yes.
Just once, I think that's all right. Yeah.
Twice, maybe.
All right.
Is that good?
Yeah,
I think that's all right. Yeah.
Cool. Yeah, so I had taken an initial stab at this using Parcel Watcher a while ago. And I think maybe it would be a good idea to start from kind of the process that I took to go through this, and then we can sort of iterate from there. So I guess the first step would be to install Parcel Watcher into the project and then sort of describe like how one might approach, not necessarily like this specific API, but how one might approach incorporating a callback type API into like wrapping it with effect. And then we can talk about kind of some of the limitations with the default way of wrapping things in effect with this particular package and how we can kind of get around them by using some of the other data types that effect provides. So I guess I'll start by installing Parcel Watcher into the project.
Can we, before installing, take a quick look at like studying the API as is with Parcel Watcher, just so that we can build a bit of an intuition, kind of like in two steps or multiple steps. Number one, build an intuition for how Parcel Watcher looks and feels right now, how the API works. And maybe then we can sketch out like at least a mental model for like how we want that to be, what that should map to in effect. Like, should that be a stream or what should that map to? And then sort of going into implementation mode just to make sure that we are like have sort roughly like a direction sorted out before.
Sure. I think the easiest place to start would be just subscribing to a directory and kind of trying to understand what that does and what you're going to get from that. So Johannes kind of touched on this a little bit earlier, but Parcel Watcher is basically a package that you can use to subscribe to and query file system events. The nice thing about it is or arguably not nice thing about it is that it's a C++ native module. So, there's pros and cons of having those bindings, but we probably won't touch too much on this unless we get into a CLI at some point, maybe in a later EffectTime. But it's got a bunch of cool features. I think the one that we will probably stick to for EffectTime today is just watching a specific directory for changes to the files within that directory. And yeah, I mean, if we have time, we can sort of talk about some of the other features that Parcel Watcher provides, but I think we'll stick to just subscribing to and watching a directory. Before I go into this example, one other thing I'll highlight is that it does have a bunch of different file system watching backends, which is kind of interesting. So it is cross-platform. It works on Linux, Windows, and Mac OS. But depending on the platform it's running on, it swaps the backend that it's using to watch the file system, whether it's using iNotify on Linux or FS events or read directory changes on Windows. So that's kind of another nice feature of Parcel Watcher is you get automatically swapped backends based on the architecture or the platform that you're running on.
That's awesome. Since like some of the limitations I've been running into with Jokidar was some things haven't been as smooth on these lower levels, and where sometimes like I got an event triggered before the file was actually written, and then like the suggestion was basically, okay, you just have to wait a little bit before you react on that event, but that by definition made my app slower. So this is where I am hoping that Parcel Watcher can make this a bit more smooth and more reliable. And since speed is of the essence for these sort of tools, I welcome that some folks went above and beyond and tried to make it as fast as possible.
Right. And just for those who are maybe not as familiar with what a file watcher actually does, essentially the watch functionality in this case would subscribe to a directory on your file system and basically spit out any changes to that file system, whatever file system it's watching. So if you pick a directory on your file system and you decide to watch it, you'll get notified of all of the different events that come through depending on the parameters that you set up with Parcel Watcher. But basically you'd get notified if files are created, modified, deleted, that sort of thing. And like Johannes mentioned, that can be useful in a lot of different circumstances, especially when you're working with projects where maybe you want to incorporate some sort of dev mode where you want to, be able to react to a user changing files on their file system or something like that. So let's take a look at the example of watching and subscribing to a directory on the file system. So one thing you'll notice pretty quickly is this big enough? I can make it a little bigger. When looking at this example, is that we get kind of the native or old school node callback API, which it's generally speaking faster than promises, but it can be hard to deal with in certain scenarios. And so this is one thing to kind of be aware of, is that when you're subscribing to a directory, all the events that you're getting would be passed as like kind of a callback.
And to be fair, like promises wouldn't even be an option here, since it's like doesn't just fire once, but
correct.
We want to wait for something multiple times.
Correct.
So I think like observables might be the other or async iterators. But yeah, this is certainly a more a simpler API that I think most people have an easier time at least getting started with.
Yeah, I mean, I think the API that they've provided here is very nice. You basically, like Johanna said, you get kind of returned a subscription. So you're going to get notified of all the events that happen to that file system. Yeah. And then, because you get returned the subscription later on, when you want to unsubscribe from the directory that you're watching, you call unsubscribe, which is also a promise, and you end up unsubscribing from that directory. There are, like I said, there's a bunch of other features of Parcel Watcher that we probably won't touch on today because we're focusing on building kind of just a file watcher. but maybe if we have time at the end, we can look into some of the other features and how we might think about incorporating them.
And here, for example, you've just highlighted one thing that would be a hard limitation in running with observables, the fact that the unsubscribe itself is an asynchronous operation. Is in observables, while the emitter can do asynchronous stuff, the cancel callback is always a synchronous one.
That's a great point. All right. So I guess now that we have better understanding for how this works,
maybe we can build up a little bit of an intuition for how we might do this with like an effect API. Or just...
Exactly. So I think what Mike was pointing at, if I add up 2 + 2 here, then I think the unsubscribe, that's whenever we need to clean something up. To me, that sounds like a good use case for like the concept of a managed. And given that we want something that can return multiple return values and not just one, that to me sounds like a stream. So did I already hit on the major points here?
Yeah,
you indeed did.
Oh, such a surprise.
So you definitely, yeah. So
well, no, I would point out that manage is getting removed. So in the future lingo, it would be a scoped effect as an effect that acquire and release resources.
Let's build it the way how we can build it today, and then see how we would change it to match well into the future.
Hopefully just the type signature change.
All right.
Yep. So yeah, Johannes, I agree with you. This definitely lends itself to a streaming situation, because you could potentially have an infinite stream of file. If you never unsubscribe from the directory that you're watching, you're basically dealing with an infinite stream of file system events. And I forget off the top of my head, but I'm fairly certain that events here is actually an iterable of events, or an array of events. Or in the effect lingo, you can think of it as kind of like a chunk of events. We have a group of events that we're receiving at a time. So there's kind of like a concept of buffering as well with the parcel watcher, where you get an arbitrary number of events that you can process at a time with each emission of the subscription. So again, also really lends itself to the streaming API that Effect provides, because you basically get all of that out of the box, including the concept of opening and closing a resource, because you can also do that. You can basically unwrap a managed into a stream when you're working with this. So yeah, if anybody has any questions about what the things that we were saying, please let us know. Otherwise, maybe we can flip over to start sketching out how we might, in a naive implementation, take this basic API and convert it into an effect, wrap it with effect, and then talk about why that might not work the way we think it's going to.
Does
that sound good? Okay, cool. So the first thing, let me install this into the project. And I guess in this case, it would be an actual dependency, not a peer dependency, right?
Well, it would still better to use peer dependencies.
Sure. Well,
I guess like an optional peer dependency, it seems like a good
trade-off, yeah.
Good setup here. Not sure whether you can.
Can I do that from the command line, or do you?
I think the optional part we need to do separately.
Yeah. Well, anyway, you have a dev dependency on the root of the repository and a peer on the.
Yarn add -d. And then if I want to make this an optional peer dependency in here,
I think
you have another field called peer dependency meta.
Yep.
Peer dependencies meta. Okay.
And inside that, I believe it's try to autocomplete. It's a JSON thing.
I'm not getting anything.
You're not getting anything. Optional something. I'll let you know.
Okay. Well, while you're looking into that, I'm just going to copy this over into our project and comment it out. Okay. So Mike, just interrupt me when you find out what I need to put in the package JSON.
Here you have an example. I'll share it with you in the Discord.
Yeah, I was about to do the same. Exactly the same file.
Let's take a look.
Down. No, there.
Okay. Let's do that really quick so we don't have to worry about it. Cool. All right. I'm going to get rid of our silly test method here, and I'll do the same over here and leave it like this for now. So nothing yells at me. And just so you for those watching, we're running the TypeScript build server in watch mode, and we're also running vtest for our tests. So we have those running in the terminal here, just in case you're wondering what's on the screen. Okay. So I'm going to get rid of the tests for a second and think about this kind of conceptually. So usually when in the Node.js world, when we have, and even in the Scala world, when you're trying to incorporate an asynchronous callback API into an effect program, effect gives us a bunch of different combinators or methods that allow us to kind of do that type of thing. And the streaming API also gives us similar combinators which handle the incorporation of asynchronous events. So in kind of like in a naive implementation, we might think that we can just wrap this callback with the asynchronous API from effect. So let's go ahead and do that, and then we can talk about maybe like why that's not going to work the way we think it is.
Yeah, I think that would be great to kind of like approach the problem step by step, see what the limitation might be, and then what the solution might be in the data types that we have available.
And we're going to use the experimental streaming API, which is actually the non-experimental streaming API now. This has become the default in Zio, and it will be the default API in our upcoming version of Effect. So we're just going to stick to the experimental API. Okay. And then let's get Parcel Watcher in here. And obviously we'll have to fix this, but okay. So if we basically take this exact example, and for a moment, let's pretend this doesn't return a promise. Okay, if we had a normal asynchronous callback function that we were dealing with here, and we wanted to wrap this with an effect or a stream, we would probably reach for the async combinators on either effect or stream respectively. So for example, if we wanted to wrap this, it doesn't make sense for this use case, but let's just say we wanted to use effect to wrap this particular API. We can use any of oh, I forget that the names are different.
Yeah, effect async, yeah.
Right, these names are also changing in the upcoming version of effect to become much clearer, but effect gives us a couple of different combinators to deal with asynchronous callbacks, right? So the most basic one is effect async, which provides you a function which receives a callback as an argument. And if we examine the type of this callback is basically a function that expects to receive some effect as its input, right? So, you know, if we think about something really simple, like if we are just loading a file, We do pass.read file. Give it some file. We either get the file or we get the buffer. We'll actually call this buffer. The way that one could wrap a function like this, which is returning the entire, everything that you expect all at once, you could wrap this with effect relatively easily by doing something along the lines of checking first if we have an error. And if we do, we can call this callback with some, maybe like a t.fail. I don't know. This is a dumb example, so we're just gonna say failed. Otherwise, we'd call the callback with the actual buffer. And one thing you might notice is that we don't get wonderful type inference here. And that's kind of a limitation of TypeScript because of the way that we're calling this function. So when you're using the async API in effect, you should provide the actual types that you're expecting. So in this case, wow, I just keep doing that. We don't expect any environment. We are going to fail potentially with a string, and we're going to succeed with a buffer, right? And the nice thing is once we provide these, then the callback actually expects those things. So if I fail with a number here, for example, we get a type error saying like, you know, we're expecting to fail with a string. So we need to make sure we succeed and fail with the data types that we're expecting.
Lovely. Nice.
Any questions about this so far?
I think that's very similar to what Mike and I have done in the past, where we've been wrapping DFS package. So yeah, that's a good reminder. But
Cool.
I guess like one of the big differences here is like read file just returns once, or the callback gets called once, whereas like we're interested in something that calls back multiple times.
Right. And lucky for us, Stream gives us exactly that, right? So Stream also has async combinators, and we actually have the modern naming in the experimental stream. So these names shouldn't really change too much in the upcoming version of Effect. But we have a couple of different ways that we can handle asynchronous operations with the streaming API. But to Johannes's point, with the streaming API, the callback it can be called multiple times instead of just once. The difference here is that the callback that we receive here, we'll call it emit, and we'll see why in a second. This callback we can have multiple emissions of that value. We're not expecting to return and move on. We're expecting this to kind of emit a potentially infinite, call this callback a potentially infinite number of times, essentially. So when I first started considering this problem, and I thought to myself, okay, well, we have a callback-based API. It's something that could potentially emit an infinite number of events. I immediately reached for the streaming, the async combinators and streams. And so we'll just do that. And we'll do something very similar. For now, we'll just do an emit. And with the streaming API, we got kind of a bunch of helper methods. This data type emit gives us a bunch of helpers which can help us handle various situations within the stream. So for example, if we want to succeed with a value, we can, or if we want to emit a single value, where is it, single? We can emit a single value of some type. We can also emit a chunk of values, because essentially a stream in effect is optimized for handling groups of values at a time. So that's why we also expose these chunk helpers, because you can sometimes improve performance by working with groups of values at a time.
Can when do I have to decide how many I process on the ingestion side or on the consuming side?
So from the consumer side, you can sort of not think about chunks if you want to. Like if you don't want to think about
Got it.
chunks
Okay.
coming on the output side, you don't really have to think about chunks from that perspective. You can feed chunks into a stream and get the elements out, or you can get the chunk, like groups of chunks out. Like you can buffer a stream at a time. There's lots of different combinators for handling
Right.
both the input and output to a stream, but just kind of know that on the back end of the way that stream is implemented, it's basically implemented on a data type called a channel, and the channel expects chunks as input and chunks as output. It's kind of like the simple way to think about it. And then the stream just kind of abstracts over that and makes things a little bit easier from a user perspective. Okay, so yeah, we have a bunch of different helper methods on this kind of emit thing that we get back. We can also complete the stream with a value, or we can complete the stream with nothing, or we can complete the stream by failing. So there's a bunch of different ways that we can actually say that we're actually finished when we're constructing a stream. But for now, I'm just gonna go back to me, a month ago when I first did this, and just think about this like in my very naive way at the time. So emit.fail. So let's just say error for now. We'll make this all better in a little bit. And then in this case, let's do this. So you can see that chunk events is actually an array in this case, which is good for us because again, streams are optimized for handling chunks. So we can use the chunk data type from effect. And please forgive me if I keep importing things from the wrong place. I've been working on the next version of effect for too long that I forgot how to do things in the normal version, or the current version, I should say. And once again, if we examine the types here, you'll see that we don't get any inference, again, because of the way that this is implemented.
Right.
We're essentially using this function to figure out what we're returning. So there's really no way to do inference in that situation. So in this case, we can say, let's say we don't need an environment. We fail with an error. And we'll make this better in a little bit. And we succeed with a watcher.event. Okay. So this was like my first very naive stab at trying to wrap this API. And then I quickly realized that there were problems with this because specifically, if this returned a promise and did nothing else, I think it would actually have been a little bit easier. But because the subscription, we need to unsubscribe at some point, there's really no way to do something like this. And then like do this part later on, at least from the basic perspective.
Kind of like how you have in React, you have like use effect instead of like the cleanup callback.
Right. Now to that point, actually, Johannes, that's actually a really good segue into what I was going to discuss next, because again, I'm proceeding down my thought process when I first started doing this. There is a combinator, a stream-related combinator that also exists on effect that is called, wow, okay. It's called Async Interrupt. And again, I'm approaching this from my very naive original perspective, right?
That's great. Taking us on the journey you went through.
So async interrupt, if we look at the description of the method, it creates a stream from an asynchronous callback that can be called multiple times. We're using the registration of the callback. This function here that we're passing into async interrupt or async, we kind of refer to that as the register function because we're figuring out what code we want to run to actually do the emission of data. And then with the async interrupt, we can actually return basically like an effect that we can use to in the streaming world, it's you return a stream. In the effect world, we return an effect, but we can basically return something that cancels whatever we were doing inside here. So a really good example of this is like if you were using something like async interrupt.
Right. Yeah.
Right. And you had something like, you know, whatever. And then you wanted to, and this is not strictly correct, but.
Interesting. Yeah, that very much resembles sort of like the API of React use effect, even though a React effect and here an effect are not quite the same thing, but they certainly share a few ideas.
Yeah, so I mean,
I would have to say that the one of the biggest problem in React use effect is that the finalizer, which is the thing that you are returning, is a simple function, can't do any async job in that return function. In this case, you are returning a full effect, which can do whatever you want.
Yeah, that's a great point. Whereas like it's probably more forgiving on the UI development side to have that limitation, but here for like more logic heavy things, it's probably more important. Max, just a quick pointer in line 27. I think you want to await that subscribe calls already.
There was actually a reason why I left it as a promise here.
Okay. Okay.
Yeah, there's because again, I'll explain this in a second why I can't await this call. But this is kind of like you said, this is very reminiscent of, you know, what a lot of people who use React are probably very familiar with. We have some logic that we're performing, and then we also want to have something that cancels that logic at some point if our program shuts down, or if the fiber running this effect gets killed or whatever. We have a way to kind of clean up the work that we're doing. But while we have this capability in the streaming API as well, it doesn't strictly work the way that you would think, because we don't just want to unsubscribe necessarily when we don't just want to unsubscribe in the canceller. We really need a fully scoped effect to unsubscribe in all of the cases where we need to actually do the unsubscription. And Johannes, to your point, this async interrupt function does not accept a promise, right? So I can't async await here, because if I did, it would turn this function into a promise, and then I'd get a type error. And so, like, if I tried to do something along these lines, it wouldn't work. So, in any
unless
case,
there is an async interrupt effect, async effect interrupt, some other weird combinator of that type, that's not doable.
I mean, we have async effect with streaming, but I don't think we have an async effect interrupt. Yeah, in effect, we have effect async interrupt, and we have a whole bunch of other actually like interesting ones. But we have a little bit more restriction on the streaming side, because obviously we're trying to handle emission of multiple values over time. So we can't necessarily do all of the things that we can do with just a plain old effect. Okay, so again, proceeding down my train of thought, I was like, okay.
It's async interrupt, not async effect.
Thank you. Async interrupt. So I thought to myself, well, that's fine. I'll just do the cleanup logic in the canceller, right? And just FYI, for those of you who might be looking at the type signature of this and seeing the either here. So the reason why you can return an either as a canceller is because if you return an either.left, I'm pretty sure it's left. If you return an either.left, it expects the canceller to be called synchronously. And if you return an either.right with the canceller, it expects the canceller to be returned asynchronously. And Mike, you can verify that. I might have that backwards. But anyways, one side is for synchronous cleanup functions, and the other one is for synchronous cancelers, and then one is for asynchronous cancelers. Pretty sure I was right with left and right. But anyways, I was thinking, okay, we can take our cleanup function.
Not sure it's like that. It's in the same effect terms. It's you either return the effect synchronously or a canceller, not a synchronous canceller or an asynchronous canceller.
I may have it mixed up with effect then, because in the new async effect API, it indicates whether or not the canceller is an asynchronous or synchronous operation, but I can't remember which side it is. All right, so in this case, the canceller is going to be an effect. And I thought, okay, well, I could just do something like this. Right, seems logical. However, the problem being here that we haven't retrieved the actual async async subscription here. So I can't actually call unsubscribe on the promise. So I'd have to await the promise first and then unsubscribe from it. So I would, again, thinking about this from my train of thought, I was like, okay.
Because I guess we could like then like wrap it in a then, etc., but that wouldn't be cancelable, I guess.
Well, you are in a finalizer, so here you are already in a non-cancelable scope, so that would be fine.
Oh my god, I'm flat mapping.
And that's within a promise.
Yep. I had turned Vim off specifically for Johannes because I thought he was going to be for Mike, because I thought he was going to be editing these files. Okay.
I'm a Vim positive person.
Same, but Mike always yells at me. So anyways, this was like my first attempt at doing this, and it sort of worked, but it had a lot of problems. And perhaps Mike, if you want to explain like some of the issues related to handling the subscription and unsubscription in the canceller, because I think the main one is basically that you're never actually doing this until you're actually canceling it. But maybe you want to kind of go over some of the limitations here.
Oh, well, because of how promises works, in the moment you call the watcher.subscribe, the promise is already started. So in theory, this kind of code works in producing the outcome you would expect. There is only one case where we're not cleaning up the subscription. It's the case where you have an error. When the stream ends, the finalizer is not called, because this finalizer will only be called if the fiber is interrupted. And if you have an exit, the fiber goes through an exit process without calling the finalizer in this case.
Johannes, does that make sense to you?
That makes perfect sense, yeah.
Okay. So at this point, I was thoroughly confused about how we could wrap an API like this with effect. So I got some advice from Mike, and then we started thinking about how we could leverage some of the other data types that effect provides to do a little bit. Oh, sorry, go ahead.
So just sorry to interrupt here, no pun intended. Just to revisit like the first two attempts that we had, like the first one. So you basically got a working, you got a working implementation that looked very simple, but that didn't allow for unsubscribing. That would basically just run forever. Now you have one that allows for unsubscribing, but doesn't handle the error case, whereas the previous one probably did handle the error case. And now we basically want to have, we had red and blue, and now we want to have both.
Yeah,
and that's basically what we're going for, right?
Yes, yes. Yeah, to boil it down, yes, but technically this version handles some errors, but not all of them.
Right, it doesn't unsubscribe on errors.
Right, and well, yeah, there are certain situations here where the unsubscription will be called specifically if the fiber dies. I'm pretty sure that we won't actually get the canceller called properly. So
Got it.
that even
And
though
for anyone like watching this and thinking like, oh my gosh, this is like fairly complicated, etc. So just the perspective that I would suggest here, we are right now wearing our library implementation heads. So for someone like future me, I would actually not have to know how this works. I could just use the effect file watcher package and it has a stream and would basically just magically work typically the way how I expected. So that's actually the power of effect, that I don't need to like, this is a really great set of mechanisms that allows me to encapsulate the right behavior on that level. But then now wearing our head of like library authors, even there it's quite complicated. And here having these building blocks to implement this behavior makes it a lot easier than if we wouldn't have it. But it is quite complicated.
I think the goal is that from an API user perspective, like for somebody using this library, they wouldn't have to think about, am I handling all of the error cases appropriately, like to actually perform file watching. Obviously, they can handle their domain errors from doing the watching of files and like whatever, but they don't have to think about, well, am I performing the unsubscription properly? Am I handling all of the error scenarios? Am I shutting down properly? Kind of all of those things we'd like to make sure we take care of in a robust way before like the library is actually exposed.
Yep.
Okay. So yeah, so the next step was kind of thinking about a way that we could leverage some of the other effect related data types to allow us to still have the asynchronous open close semantics of the subscription, right? Be able to like create the subscription and then also unsubscribe from that subscription. So we kind of have open close semantics that Johannes pointed out very astutely that lend themselves very nicely to a managed resource. But we also have the concept of streaming here, and we want to be able to capture all of those things over time. So there is another data type in effect, which we decided we were going to incorporate into our function here called queue. One sec, we can get it. And queue is a really, I think it's somewhat underutilized, but it's a very cool data type. It's a lightweight kind of in-memory queue that you can use to perform. It's a fully asynchronous queue, so you can have asynchronous operations that you can use to write to the queue, and it's back pressured depending on the strategy that you use to create the queue. You can either have a sliding queue, a back pressured queue, you can have an unbounded queue. You get a lot of benefit out of the different types of queues that you can actually create here. And the nice thing about thinking about incorporating a queue here is you're thinking, well, what if we store the events temporarily in a queue, back pressure them into a queue, while still giving us the open close semantics, and kind of like do that within a managed instead of using the primitive exposed by stream here. So we get the open close semantics, we still get the streaming API, but we no longer have all of the limitations of the stream.
Basically, first create a managed queue and then use the managed queue to produce a stream by reiterating the poll on the managed queue.
Got it. And I imagine like that the stream under the hood also has some similar mechanics. So we're basically just decomposing some parts here to fully leverage our use case.
Yeah, exactly. So let's start out by maybe like scrolling down a little bit here, and let's kind of scrap this for temporarily and just create a new function, something that we think we might expose in the future, like watch or something. And for now, we'll just take a directory. And we won't annotate a return type for the moment. So to keep this like simple and iterative, let's take the step of first creating a managed resource out of our subscription here. So maybe like I find that sometimes when I'm prototyping, it's helpful to use the generator versions of effect and stream and all of that because
yeah, you need to know less ahead of time, like how you combine things, and like later on it's easier than to refactor it.
Right, it just makes it a little bit easier, and you can sort of iterate, and you can actually program in an imperative fashion for a period of time, and then you can kind of take what you've written as long as it works, and you can sort of get rid of the generator iteratively if you don't want it to be, if you don't want to implement it in terms of a generator.
You have to take a parameter in the generated function.
Oh yeah, I should have used this. Do I still have this? No, I don't. Let's make a $sign for now, in honor of observables. Okay, so the first thing that might be a good thing to do is actually creating our stream, not stream, queue. And for the moment, we're going to ignore a couple of things. We're going to ignore the different types of queues that we have available to us. And we're also going to ignore back pressuring in the queue. To a certain degree, the queue will handle back pressuring for us, but we're going to ignore like capacity and all of that sort of thing for the moment. And we're just going to create an unbounded queue. So let's do a queue dot make unbounded. And we're going to have
This is an effect.
Right, we're returning a queue of effects, which we can say, for now, we don't know, or maybe we don't know what we're doing. So for now, we can just return an error. And for now, let's say this, because I think this is how we originally decided. I think this is how I originally did it. And you can actually shut down a queue as well. And since we're in a managed, we might as well.
Well, would shutting down a queue mean basically canceling all the operations?
Shutting down a queue means canceling both the pollers and the pushers.
Okay.
Because both pushing and pulling can be yielded in an asynchronous way. So you can push asynchronously and pull asynchronously. So your pull is waiting if the queue has reached the capacity. The take is waiting if there are no elements. When you shut down a queue, both of those operations also fire the interrupt.
And just as like a quick aside, what Mike said is 100% true, but I find it very cool the way it's actually implemented, which is using promises, not JavaScript promises, effect promises on the back end, which would be a really cool topic for another EffectTime at a certain point in time. But using promises is how that back pressure is actually implemented. Again, not
Guess
not
we'll
JavaScript
have to make the promise to cover that another time.
Okay.
Fragment hitting.
Yes. So you can see here, completely ignoring that, that we're returning a managed resource here. But because we're in a generator, we can yield it.
With a star.
With a star. I don't have any of my helpers in here.
Yeah, we forgot to port the helpers.
And now we actually get access to the actual queue implementation itself. So what we're saying here is basically we have a queue in which we can enqueue effects, which can either fail with an error or return an event, a watcher event. And we basically want to, the reason we are returning an effect instead of like the actual event is because these are going to represent asynchronous emissions of our stream at a certain when we actually incorporate it. So,
or rather, even if they are not asynchronous, you still have exit to represent a full exit case. You might have errors, you might have defects, and effect can represent all of those cases.
yes.
It's like a more powerful either in this.
Yeah, no, that's actually a really good point. And again, we're kind of ignoring for the moment different types of queues that we can actually implement for the backend for our watcher. Maybe as a enhancement of the library, we can expose different either different versions of watch, watch unbounded, watch, but sliding, whatever. Or we can expose like a parameter that takes in a queue strategy or something like that. Probably just easier to expose multiple combinators, but those are kinds of some of the API level decisions to make down the line once we have something that's working. Okay, now we can maybe wrap our watcher. So I'm just going to sketch this out. It will become clear in a moment. So instead of emitting errors and chunks into the stream, we're actually going to try to, what we want to do in this case is we want to emit the events into our queue, and we want to also let the queue know if there's a failure, right? So since we don't have the streaming API here, we want to just enqueue those things. So let's see what happens if we just do, oh my God. I'm operating in TS Plus world right now. So let's say if there's an error, we want to offer a failed effect to the queue, which fails with this error. And if we succeed, we're going to offer a success value. And it was at this point, I believe, that I realized that we actually want to emit a chunk into the queue. Because when we succeed here, we're going to do a chunk.from events. Now, there's a problem here, which is that because these queues are asynchronous, that just like Mike said, they have back pressure semantics that are backed by the whole effect system. Offering and taking items from the queue are effectful operations, or effectual, however you say, whatever the proper term is. You're basically performing an effect when you offer an item or take an item from the queue. So that poses a problem here, because running this offer, as some of the previous effect times have shown us, will just return the effect. It won't actually run the effect. So how do we actually run an effect? Well, we need a runtime, right? And we have combinators that can help us access the current runtime to be able to run effects. So let's do a, what is it called? Runtime?
Yep.
T.runtime.
Pretty much.
And again, a lot of this can be improved, but now we can basically take these effects and we can use the runtime to run those effects on a fiber. Right, so runtime.run fiber. And now we've essentially
What does that, what's that run fiber, what does it return?
A fiber.
Yep, a fiber.
It's the lowest level that you can go on the run systems.
I guess that's fairly a fairly rare case that you actually need that.
Yeah,
you almost never need that, but for a case where performance matters and you don't care at all about doing anything else post the effect that is running, you're not taking care of watching the exit value and anything else. Yeah. You can just do run fiber and doesn't allocate any any infrastructure to just wait.
Got it. Okay, so it's a bit of a trade-off where
You could do run promise there.
Right. Right. So there's like, yeah, there's a couple, I mean, there's a few different methods on the runtime, I think. But I think Fiber is probably, like Mike said, the
got
maybe
it. Okay.
most performant, but maybe like worth a discussion at a later point in time. But again, if we just examine the type here, once again, we're left with an effect that returns an async subscription. So we've effectively got ourselves back. So that one's for you, Johannes. That we've effectively got ourselves back to the situation we were in before. But before we kind of did this piece of unsubscribing or whatever, we've gotten ourselves kind of back to the position where we're returning an async subscription instead of in a promise. Now we've got it in an effect. But that is beneficial because now we actually have a way to handle this. So let's continue. So we're running this within a managed, right? And we have this async subscription within an effect. And as we've done above with our queue, we can take an effect and create a managed out of it using make exit. And make exit gives us access to the resource so that we can actually do some operations with that resource to shut it down, right? And in that case, that's exactly what we want here. We want access to the subscription so that we can properly shut it down.
Inside make exit.
Yeah, I know. I know.
And it's inside m dot.
Okay. All right. This is why TS Plus. Everyone should use it. Okay.
The missing parentheses.
I told you Mike was going to need to edit these files.
And editing live.
And again, the unsubscription, as we saw on the previous screen here, the unsubscription is an asynchronous operation as well, which we hope doesn't fail. If we wanted to be really robust here, we could do a try catch promise, I think it's called, or try.
Yeah, in this case, you need to die anyway.
Right. So we would do an or die in this case, most likely. To do subscription, unsubscribe, and we can pipe this to, or we can just do a t dot or die.
This is already what's going on here. The t dot promise.
Oh, that's right. I forgot on the, yeah, behind the scenes, it's going to die no matter what, right?
Because I should say in the new effect, t dot promise has an unknown on the error and automatically does a retry, not a retry, a try catch.
Mm-hmm.
So it's more explicit. If you want to have a defect, you're gonna have to do t dot promise or die.
Right. Okay, and now we actually have a managed resource here. With our, we actually have like exactly what we wanted here, a managed resource that returns an async subscription. And in this case, all we have to do is run it. Please point out anything else I do wrong.
No, that's correct.
Okay, so at this point, we've run our async or our subscription. So if we actually looked at the return type here, we have access to our async subscription. We don't really actually need it because all of the values that we're emitting from that subscription are going into our queue. Already. Exactly. Yep. So now,
and the closing of the subscription is already handled within the manage.
Now that we've done that, we can actually create our stream. And
you could do two things. You could even return directly the queue here, and you will have first a managed queue, like we said at the beginning, and then from a managed queue, you can create the caller.
Mm-hmm. Yeah, that's actually like an interesting thought, is like we could expose, you know, different combinators from here that have different levels of kind of indirection in terms of like getting access to the events. but from the implementation that I landed on, or that we landed on when we first did this, we'll stick with that for now.
Yeah, but I mean, even sticking for that, for the purpose of explanation, is better if you extract this managed, this m.gen into a constant within the same function even. That's like make managed queue.
Right. Okay. And then what did you want me to do from here, Mike?
As a stream.unwrap.
What does unwrapped managed here mean?
Yeah, we need the actual,
we need actually the stream.
Yeah. So unwrap managed is a method that takes a managed that returns a stream. Okay. So in this case right now,
if we don't need it, we don't need to go into it now, but
no, we do need it.
Okay.
But so unwrap managed is what we're going to eventually use to transform this whole thing into a stream, because it basically takes a managed resource that returns a stream and converts that into a stream. So it basically pulls the stream out of the managed resource.
Well, let's write the stream and let's see the signature.
So we can do this if we wanted to, I think. Oh no, we can't.
I think you have to use the repeat effect.
What does this give me? Yes, okay. This gives me so what I'm doing here is I'm basically taking the queue, pulling off an element, and then flattening it, because if I didn't flatten the effect, I'd get a nested effect. So you can see here, I'm getting an effect with a nested effect inside of it. But the reason why
because we had a queue of effects. So when we pull out one effect from the queue, we got back our effect. Pulling out is also an effect. It's like you have a promise of a promise.
43, we basically have an effect in there.
Yeah.
Right. And because really, what are we trying to do here? Like taking a quick step back, what are we trying to do? We're trying to dequeue the effect and then run it, and then take the elements we get back and put them into a stream.
But basically if you wouldn't flatten it, we would just get like effects back. But now that you flatten it, this is actually the point where we either get the value, or in case of an error where it actually fails.
Yeah.
Yeah.
Makes sense.
So we're almost there in terms of actually creating our stream, right? And we actually have a helper method on stream, I believe. Repeat effect chunk. Yep. Beautiful. So now, if we look at the type of watch, we're still not 100% there. We're like 90% of the way there. Because now, Johannes, this is exactly what I was saying before. Right now, we have a managed that returns a stream. Right? We have a managed resource that returns a stream. But what we want is the stream. We don't care about the managed necessarily. Right?
We want another type of flattening there, basically.
Right.
But what about the semantics of the exit?
So the combinator within stream, there's a combinator within stream that handles all that for you.
Got it. So it basically pulls in, there's like a similar to how managed has an exit thing, stream also has an exit thing. So it basically just relocates that basically into the stream.
It basically move the stream to be first acquiring the resources, then using the stream, and then closing down the resources. Streams themselves can handle resources quite well.
Right. So we can probably just wrap it at this point. Oops. S.unwrap managed. And also, just for those of you who are curious, there's unwrap managed. There's also unwrap, which is specifically for effects. Unwrap managed handles managed resources. This
I would be curious to know if getting rid of managed also gets rid of the two unwrap, and it's simply unwrap.
I believe it is unwrap scoped in the new version. I think that was how they renamed it, because I think they still require a scope. So at this point, now that we've unwrapped our stream from a managed, if we look at our type of watch, we have the type that we were actually hoping for here,
Nice.
which is very interesting. And the nice part about this is we have a couple of hidden performance benefits here, which is that since we're returning a chunk in here, so we're actually, there's layers of buffering happening here. We have a queue of chunks, a queue of effective chunks, right? And because instead of returning like the individual events in this effect, since we're returning chunks, we actually, again, get that benefit of having the chunked emission of resources into the stream, that kind of like buffering that happens.
You probably
I know.
want to use the directory here.
Yeah, good point. Okay. That's what I get for copy pasting.
Otherwise, we get Mike freaking out that this is also an effect, calling process current working directory.
It is an effect.
You would be right.
So yeah, at this point, we have something that we can actually use, and probably would be kind of fun to just like do a smoke test of this really quick instead of writing a test, because I think that's fun. I like tests, but I like smoke tests as well. And I also like annotating return types. So one other improvement we could make here is improving the error type. So we could do like a file watcher.
Yeah, I guess we don't have quite enough time to write like full tests, etc. So I think we should just like try to do a first script to run it by hand, and then wrote it up here, I think.
We have our nice examples directory.
Perfect.
Yeah, this will be the last improvement we make before we just run a couple of quick little.
Just have a read only on the error there in line 11.
Thank you. And we want to basically take this and put it here.
Yeah, I think you need to. Oh no, never mind.
And now we have a nicer type here, which I'm going to annotate because I'm that guy.
I'm also that guy.
Both guys know that you have a refactoring with VS Code that can do it automatically.
Yeah, but I just like making things difficult for myself. Okay, so let's make some stuff.
Awesome. So it turns out we were not after a sum function after all.
Well, we could run some function on every file.
I am fairly certain I can do something like this. No. Yes.
Relative to the parent, probably.
I don't know if we run it with workspace, if it's gonna point to like this file system, like by default, or we'll see. Then we want to do.
Let's take like, I mean, off a stream, let's take like the first two.
Or
whatever.
Okay.
We log everything. Run collect collects all the outputs in an array, and given this is going to be an infinite stream,
Thank
I
you, Mike.
fear here we're going to blow up memory a little bit.
Let's just log out the events for now. Oops.
It's a remote server. It's fine.
Okay. So let's do this.
All right.
I don't know if this
exciting.
I don't know if this path is 100% correct, but we'll work through that in a second. Dev. So
As we can see, we see nothing. So that seems correct.
Yeah, so it should be, because we're draining the stream and the stream is basically infinite, we shouldn't, the program should not shut down. So behavior is as expected currently. Let's
I was
make,
told once to, instead of here line 14 T run promise, to use node run main.
yeah, but I don't have effect node installed right now.
Okay.
Ah,
Oh,
there we go.
wow.
There
Look
we
at
go.
this.
So now if we say, this is really cool. There we go.
Nice. I mean, we did not expect, I mean, this could be actually now, if, yeah, well, we could install the node package with FS and then kind of like flat map over each stream thing and actually also get the file contents. That would be now something that's really easy to do. But I think that could be left as an exercise for the keen observer here.
Yeah, so
Either that or we do it in 5 minutes.
All right, we shall be the keen observers. Let's do it. Like maybe install node as a def dependency.
yarn add dash d add effect. Yes, node.
I hope that I have published the FS module actually. That would be fun.
So well, since we did that, we can also do run main from runtime. I keep trying to use Vim.
Yay.
All right.
So
I think we can keep that tab and then map like chain afterwards, and then log the other thing as well.
do you, okay. What do you want me to
Like
do?
line, after line 14, do like S chain
It would be
or
a-
chain effect or whatever that's called.
It's tap. Tap is the,
No, it's map effect if you want to change the result type.
Yeah,
too.
yeah, map effect. Event. And now let's see what we got in the FS.
Read file.
Yep. And let's just add this as like in a tuple or something.
tuple?
Or like basically just
Do not lose the path, you mean?
create a new event where it also adds the file content. Basically, maybe add a property to the event object where it adds like a contents.
Oh, I see what you're saying.
Could be t-struct.
Yeah,
Yeah.
you already have events. That's file, like buffer.
What is it again? Buffer.toString, or it's,
Let's say to string UTF-8, but that could also fail or not. It's not encoded in UTF-8. That I guess it's an effect. So.
yeah, whatever. We can do it exactly what Johanna said. We can do this. We can do. What were the fields again?
Event, I would say event.
Yeah, we can just keep it as event and then have the contents.
Oh.
Consent. I think here we actually don't want succeed with, but we actually want to call the FS thing. And that returns
Returns a buffer, so to print
I
the
guess
buffer.
here we want to map.
We don't chain actually, given
what?
We're gonna have to do a.
All right, Mr. Correctness Officer.
Precise.
It's very precise.
There you go. Tells
And
us
then-
obviously we need to provide the file system. I think we have it as a layer. Provide some layer, yeah. Live make live fs. No, that's the make function. Live fs. There it is. And we should
Okay.
still log something probably.
Oh yeah. Can just copy the one above.
Let's just do it like this. Since we're getting the event anyways.
Yeah.
I think would be cool to keep like both, to keep both log statements.
Whatever your heart desires, Johannes.
That's absolutely what my heart desires. So, okay. Okay. Now look at this. This is really cool.
Really, really cool.
Nice. All right. This was a big success.
Yeah, so
Great success.
so there's definitely ways that we can improve the things that are exposed by this module. I think the watch functionality is like the minimum that we can do.
Yeah.
There's other features and whatnot, but
But
hopefully
we've
this gives
sort of like have now first vertical slice, and now we can sort of like sprinkle different variants over it, make it more configurable, etc.
right.
But yeah, that's great.
Hopefully this gives everybody a little bit of a better idea also to handle some less typical asynchronous operations with effect, and how you could potentially approach those problems instead of just relying on the async combinators. So.
That's awesome. All right, that's great. Thanks so much, Max, for sharing your streaming wisdom with us here today.
It's done.
It's been super super interesting for me to learn about these pieces of effect here. And yeah, guess unless there's any more questions, we'll probably call it a day here. And looking forward to seeing you all back in a few weeks for the next episode.
Sounds good, guys. Thank you.
Thanks so much.
Sounds good. Thank you very much. Bye-bye.
Alrighty. Bye-bye.